Hello, my name is Srđan Vesic. This is Predrag
Hi.
Ivanovic, and we are presenting joint work with Bruno Jun. The topic of our work is how graphical representation of arguments and attacks between them impacts human subjects in reasoning, and in particular in compliance with principles from the area of graded argumentation, semantics. Let us just very briefly mention some related work. So we know that Kramer and Guillaume show that some of the semantics for extension-based case are better predictors of human judgments. And another remarkable work is that of Rahwan and colleagues, where they studied the notion of reinstatement. So reinstatement means that if subjects see just argument A is deemed as pretty strong or strong, once it's attacked by B, A is going to be much weaker in the eyes of the participants. And then the final part of this experiment is when C is added, C is going to defend A, and this is what is called reinstatement, because A becomes reinstated and becomes strong again. So we know there is data to support that some of those concepts from our area are agree with what humans think. And we wanted to study some other questions in these experiments, namely in the area of graded semantics, but also we are particularly interested by the question if the viewing the graph with the arguments and attacks is going to change something in how humans comply with the principles. Graded semantics, very briefly, are argumentation semantics. So we suppose we are given an argument graph. Nodes are the arguments, and the edges of this directed graph are the attacks between them. And then a semantics is a function that attaches a score to each of the arguments. So score is just the number between 0 and 1. And here is an example of well-known age categorizer semantics from the literature, where you can see different scores attached to different arguments. Let us show you some of the principles from the literature. Anonymity says that the names of the arguments should not influence their acceptability. So we're just looking at the topology of the graph. Second, independence says that the acceptability of degree of an argument should not be affected by unrelated facts and arguments. So something which is not even connected in the graph should not influence the acceptability degree of an argument. Then void precedence is a very simple one. It says that if an argument is not attacked, then it must be more acceptable than another one which is attacked. And finally, maximality says that non-attacked arguments should have maximum acceptability degree. So in this theoretical setting, it's 1, but it can be different. There are many more principles, but we are not studying them, and we are not talking about them today.
It's not 1, it's 4, I think.
It's 0, 1 in the theoretical case,
okay.
And now in our experiment settings, as you are going to see, it's going to be 1, 2, 3, 4 to make it easier for the participants.
Yeah, right. So we wanted to examine several things here. When we were talking about our study, we wanted first to see if people actually comply with those principles, which are relatively abstract. And we also, but our central question was if graphical representation of arguments is going to enhance people's performance on these tasks. And if people who are more prone to comply with one principles are also more prone to comply with the other principles, and if those correlations are different in two groups, graph group and no graph group. We also included some cognitive measures to relate them to these compliances with the different principles. So basically, design of our study looked like this. We had 6 phases, or would we call them phases?
Yes.
And we randomly assigned 98 participants in 2 groups. So groups were not actually of the equal size, and as you can see in this table. So do you want to describe how the procedure
Yes, thanks.
looked like?
So now we had those 6 phases. So first we had tutorial because those people didn't have prior knowledge in argumentation. And then we had a quick test to see if they actually understood those concepts, and they did it pretty well. We were quite positively surprised. Then the third part was the main part of the experiment. And we are going to give you examples of tasks from this part very soon. The only difference was here in the third part, and it was that the graph group, obviously, people from this group were seeing a graph, so they were seeing what you've seen a slide ago and that you're going to see again. And no graph group had exactly the same dialogues, the same text, but they didn't see the graph. And then you can say about the second part.
There were 16 tasks in no graph group and the graph group, and the only difference was if a graphical representation of arguments was presented. And after that, after those 16 tasks, participants were presented with the 3 cognitive reflection tasks, and also with 10 statements to which they expressed their level of agreement, and 5 of those were related to need for cognition style, and the 5 were related to faith and intuition.
So yes, they had 16 argument rating tasks, and in each task, their task was to, for each argument, choose a score. So is it 1, 2, 3, 4, very weak, weak, strong, or very strong? So this is an example we don't have time to read, but you can pause and read if you wish. And so they had some dialogues and also the graphs that corresponded to those dialogues. So here we can illustrate what, for example, void precedence is. It says that a non-attacked argument should have a greater score than each attacked argument. So here, if a participant said that C is strong and A and B are very weak, then we can know that that person does satisfy the principle on this example. So we don't have time to go into more details about maximality and other things. Let us very briefly just show the independence. So here the idea is to have 2 different tasks. So participants do not know that they're being evaluated on independence because they don't even know what independence is. But so here we have 2 tasks, and then we made sure to have some different examples and different tasks between of them, so to have them a bit separated. And on the left, they see only this dialogue and this graph, and then a couple of questions later, they can see this dialogue and this graph. And so the point is that adding CD should not change what we think about A, B. So if I say that A and B are equally strong in task 1, I should also say that A and B are equally strong in task 2 if I want to satisfy the independence. So Peja is going to talk a bit more about other measures.
We had those cognitive measures. The first one was cognitive reflection test, and this is a typical task from this test. It triggers participants to provide intuitive but incorrect answer. We also had those 10 statements, and participants were asked to state their agreement with those sentences by using a 5-point Likert scale, and you can see those on the graph. So those are results. And
so let us talk about principal compliance. So some of them are pretty low. So like anonymity, we don't have time to go into all the details. Anonymity within task, but just very, very briefly, you can see that here first the graph group has much better compliance. Here, because they have much more structure, they can tick much more and see all the attacks, etc. So there's also a big difference. And also for maximality, we have the score, which is pretty low, even in the graph group. But so it's all about also reading what's inside of the arguments, and also about prior knowledge. So people have some knowledge and some doubts. So even if you give them just one argument, if it is not attacked at all, they still hesitate, and they can see, oh, it's okay, it's 9 out of 10, or in our case it might be 3 out of 4, yeah. Which is not shocking, which is actually quite rational, because they don't really switch their other knowledge, and they have some reserve in reasoning.
Right. So, but what is the main result here is that for each of these principles, performance of subjects was much better in a graph group. So basically, when you present people with a graph, they comply more with the different argumentation principles. This difference was highly statistically significant, and the effect size of the graphical representation was quite large. It ranged from 0.7 to 130. So, and what is more, in the graph group, correlations between compliances to different principles were much more correlated, which can be also seen in these two tables. So basically, when people are presented with the graph, their responses are based on a much more solid ground. The reliability of their responses is higher, and the correlations with measures of compliance with the other principles is also higher. So, and we also have this result that tells us that only in a graph group, correlation with cognitive reflection was significant with different compliances, and for faith in intuition and for cognition, those correlations were not significant in neither of two groups.
So we have so much to say, but no time. So thank you for tuning in. If you have any questions, we would love to talk to you. Drop us an email. We can organize a Zoom. Or if you are watching this live at Amas, see you in 10 seconds for the questions.
Yes, right.
Thank you.
Thank you. Bye.